Yes.
Okay.
Well, I'm Howard Brake. I've been with the Energy Office since Noah put the animals off the ark. And since we're so teeny and some of us don't know one another, why don't you just say your name and who you?
I'm Nick. I'm with Hawaii Energy. How's it? I'm Brenton. I'm with Element Environmental.
And everybody knows Gail.
Gail, with State Energy Office. I'm Elizabeth, also with Hawaii Energy. Eileen Stewart, Hawaii Energy.
And
Fortune Hurdell, Hurdell Studios.
Yep. And Madame, you have not introduced yourself before sitting in, Madame? See, you have to introduce yourself. As a latecomer.
Sorry.
And your
You're not
name
late.
is
He's just giving you a hard time.
from
I'm from AHO. Yeah.
Big Firm. And everybody knows. you.
No, not everybody.
Okay. Jill, introduce yourself.
Jill from Australia.
Yeah. And this teeny little fellow in the corner,
I'm Ben, independent.
retired at the age of.
I'm Madu, I'm Babe.
With who?
Baze.
And also,
I'm Gigi, I'm with HL.
and everybody knows Rick Myers, he doesn't know Andrew.
Rick Myers and retired.
But somebody will suck him out of retirement, I guarantee that first. So we are with the,
Everybody go.
oh, yes,
Sophie, Energy Advisor, Hawaii Energy.
and you'll be talking all about Hawaii Energy in a few minutes,
Yeah.
okay? So we all know that Hawaii leads the way in towards 100% energy efficiency. And the easiest way, quickest way is to ensure that Hawaii's homes and buildings are very, very energy efficient. And something I've learned in the last few months, hanging around with the modeling crew, is that perhaps the easiest, most cost-effective way to achieve energy efficiency in building is by modeling. Have you a new building? We are concerned with heat mitigation. What heat? See, do we turn it this way? Do we turn it that way? Window to wall ratio? What type of window? Do we want to shade these? What if we do a lot of north and a little south? Yes, with a little link of the risk. All this is about taking your risk and achieving some pretty massive energy efficiency. Wait out front. And help us to flick those risks. Here, Jessica, how about a queen of risks?
Oh,
There we go.
Thank you. That's nice. I think you turn this off. Yeah. Switch. Hi, everybody. Thank you so much for being here with us today. We're going to be talking about a variety of energy modeling tools. And really, the objective of our session today is just to show you the various options and the expansive options. I know when you first start modeling, you can kind of get stuck in a place where it's like, what should I use and how does it work and what's going to work best for our workflow. And so we're really trying to find a way to introduce it to you, give you the general idea behind it, and then allow you guys to make that decision. So this session is going to be one continuing education hour. This is our course description, our learning objectives. I'm going to skip through all this. And this is the second session of a three-part series that we're doing on energy modeling. Our third is going to be a hands-on energy modeling workshop where you're going to get to be able to click around within a energy modeling software. And that's going to take place in early 2026. We're really looking for feedback from session 1 and session 2 in order to inform session 3. So start thinking through things that you want to see in the future. So my name is Jessica Lee. I work within energy models every single day at a firm called IMEG. We have Eric Coldrup virtually on the call with Coldrup Consulting. He's been doing energy modeling throughout his career, and so he's really knowledgeable. Excited to learn from him today. And then Ron Chatterjee with the State Energy Office also has done energy modeling in the past. So excited to talk about that. A couple of acknowledgements: Gail Suzuki Jones, Howard Wigg, Thor Mendez at the State Energy Office, and then Karen Shishido, Sydney, and then Sophia from Hawaii Energy. And thanks for the sushi as well. And then also thanks AIA for hosting us yet again. This is our agenda for the day. We're going to talk a little bit about single family home with the HEED software, along with commercial energy modeling with Sapphira, Autodesk Insight, and C-Scale, and then touch a little bit, but not as in-depth, on Climate Studio and Forma, and then we'll have the end for some questions. So I'm going to pass it on to Eric to get us started.
Thank you, Jess. Nice to be here virtually with you all. So as just noted, we're trying to give a little bit of an exposure to the range of early design tools and then give you a little help deciding perhaps where to start. Oops. The remote controls are a little funky. Okay, so before we get to the tools, let's just revisit this question we also covered in session 1. If you attended that, it's like, how is BAM used over a project life cycle? And the focus today is the tools that are most useful during pre-design and schematic design for the types of analyses that are circled here. Hopefully that's pretty clear. And these are some of the tools that are developed to focus on early design. So the first 4 we're going to talk about is just noted, and then the last 2 we're going to just kind of briefly touch on. Some things to note here in terms of input. These use different software and different workflows to developing the model. Could be SketchUp or Revit or Rhino and so on. And most of them do energy calculations, although there are a couple that C-Scale and Forma that don't really do an energy model, but just have like a benchmark database lookup. And then each of them has some other functions that are useful, like daylighting and shading and so on. But our focus today is energy. And since I'm an energy modeler, I also didn't want to neglect our detailed energy modeling tools that you can see there over on the right. So these tools can also be used very effectively for early design modeling, but they probably have a bit more of a learning curve. So they take a little time before they could be used effectively for that usage. So single family home example. So this is our first one, and then we'll get to a commercial building in a few minutes. It's just like a basic 1,600 square foot, 2-story home. And the baseline parameters are like a 2018 IECC or the current Hawaii Energy Code performance. And then we'll look at some options to that, or alternatives rather. Oops. Sorry, trying to get slides to go backwards and they're reluctant. Okay. So, I also, before we get into that, I think it's also good practice to try and track down some benchmarks for energy information before you start an energy modeling study. It helps you to judge whether your results are reasonable or not. And these data here are from a study by UH. There's a reference down there at the bottom. It's done a number of years ago. So they monitored 7 homes in Kapolei. And from their results, they showed anywhere between around 6,000 and 14,000 kilowatt hours a year of energy consumption. And you can see the breakdown between, things like air conditioning, water heating, and so on. So just keep those numbers in mind, like 6,000 to 14,000. So let's talk about our first tool, which is called HEED. So this was developed at UCLA. It's a desktop application, and it has its own internal energy calculation engine. It's California oriented, so it's kind of got a bunch of defaults that are like California Energy Code defaults, but it still can be very useful in any other climate. We'll see that it has kind of a old-fashioned interface, but it still has some really powerful capabilities. Oops. Sorry for the delayed driving. So heat can evaluate a wide range of features. So both the housing design, but then things like insulation, window performance, thermal mass, solar reflectance of the surfaces. You can put in trees in neighbor buildings for shading. You can vary the air leakage to see the impact of that, change the water heating, including heat pumps and solar thermal. You could put in a PV system and then modify the AC efficiency and even change appliance energy if you want. So it's got a lot of features in it. So the next slide here, we'll go through the process of starting a project. So let me pause this for a second. So, like when you use heat, you create a project and you define schemes within the project that represent different design alternatives. And when you create a project, as you'll see, you get 2 schemes by default for free, no charge. One is a California code complying home, and the second is an efficient alternative that the software comes up with. So you're kind of like starting at scheme 3. So I'll just hit play again. And so you put in a name for your project, you enter some basic information like the floor area, and you choose a weather file. So this is Honolulu. And then whether or not you've got an attached garage. And now you've got results for the first 2 schemes. And your third scheme, you will type your own name in. And when you hit OK, then you'll see the results. The third scheme is the same as the second scheme now, so there's no difference in results yet. But once we move forward, there's some design strategy information, and then you get to the input screen. And so we'll get to that next. So let's do a quick tour of the input screens. To enter a scheme, there'll be some next and back buttons. So you can step through a series of screens, or you can use a couple menus to access the information. So that's what you'll see here. The next and back are down at the bottom. Here we've stepped to the orientation input where you can drag and reorient the building and then enter window details. Then there's a window editor. This is kind of funny. By default, all the windows are out at the property line, but then you can drag them and put them to specific spots on the facade. The simulation still works when they're out on the property line, but then the shading may not. And then there's a bunch of basic inputs for envelope and everything else. And then there's a menu of more advanced inputs. So that's how you kind of the basic idea with how HEAD works. And then I wanted to show the idea of creating a new scheme. So the baseline scheme that we've got is kind of all the baseline energy code. And then the new scheme will add exterior foam board to the wall insulation, and we can display the results. So you copy a scheme, you give your new scheme a name, like wall plus R5, and it does a really quick calculation. And now I go to the wall assemblies, and you've got some default wall assemblies you could choose from here. You could also use more complicated advanced inputs. And here we see the results, that we got a little step savings in results for that R5 installation. Exciting, eh? Then just one of the features is you could add neighboring buildings and trees. So we'll see the geometry editor, which is a little funky in HEAD. There's a grid, a 4x4 foot grid, and you create your model by clicking on these grid points, and you build up your model in chunks of 4x4 foot building or other objects. So it's a little limited. It models any building as long as it fits into a 4x4 foot framework. But here, we're going to the floor planner screen, and down at the bottom there are these buttons where you could do things like add neighboring buildings. So it's clicking adding the neighboring building, now going up to the second floor, and you're adding a second floor on the neighboring building. And then you can see in the lower left how that model's getting built up. And now you can also click around and add trees. And so all of these objects will then shade the model. And this is the window layout tool where you can go and put the windows in their appropriate locations so that the neighboring buildings and everything actually shades them when it runs the simulation. All right. And then let's just get a quick look at some of the results views. They have these kind of interesting 3D results. We'll see some examples of the loads reports you can get. So you can choose, you can see loads from individual envelope components. And so, for example, this is south windows, west windows, north windows, east windows, and you see the different times of day. And these plots show the average day for each month. And this one is the total energy use. So you can see the profiles for each month of total energy use. And then we have couple more. HVAC sizing, you might be interested in these results. You know, it's not just all about EUI, but these measures can have an impact on the HVAC sizing, which is useful information for design. And then the last video is not related to the energy modeling directly, but it'll allow, you can see animations of shadows and sunlight on your model. So here, you can choose a day of the year, and then you watch how the sun shadow patterns change over the course of the day. And then you can also switch to the sun's eye view. So like you're sitting on the sun looking at your building and see the animation of your building for each hour of the day. All right, so then shadows and sunlight. So that was that one. And I just wanted to give one quick example of the kind of analysis you might do. So this is wall analysis. So 5 different wall constructions from the base case R13 wood frame, adding the R5, which we saw. So we'll see that there's a little bump in savings there. Then a concrete masonry wall with integral insulation. So not much insulation at all. We see the energy go up a bit for cooling and fans. If we add R7 exterior insulation on the concrete masonry, then we see that it comes down right in line with the baseline wall. And what if we add like a white coating on the outside, 80% solar reflectance with no insulation? We see it improves the performance relative to just a normal color CMU wall, but it's still not quite where the baseline is. So this can be useful information, of course, right, in deciding your wall construction. Okay, and then just a couple observations on heat. So there are a number of limitations, as you maybe see. You know, you can't import geometry from another program like Revit, for example. And then you've got the floor plan on a 4x4 grid, which is something of a limitation. It doesn't automatically create an IECC or Hawaii Energy Code baseline. It does do a California baseline. And then some of the defaults are related to California Energy Code compliance. So you do a little tweaking to kind of come up with an appropriate Hawaii baseline, but it's not that hard. Output data export is limited, so it's a little tedious getting some of the results out if you're interested in more than just the graphs they provide. And it may not work on some newer versions of Mac OS, which we kind of need to check.
Eric, Jill has a question.
Sure.
Hi, could you go back to the slide with the wall assemblies, the frame wall and the CMU wall?
I think so. It's not, there it goes. Okay.
Yeah, so what is integral CMU wall integral? What's the integral insulation piece of that?
Integral insulation is just sort of like insulation poured into the cavities within the CMU wall, the ones that aren't grouted. So it It provides a little bit of insulating benefit, but not really a whole lot because you still have the concrete thermal bridging of the webs in the concrete masonry unit.
Right, does he give you the option to do a full mass wall? So fully grouted CV wall?
Yeah, you can do solid concrete. I'd have to look closely. And then there's in the advanced input, you can sort of model pretty much any wall you want. These are some of the ones that are just standard choices that are options, sort of easy ones.
Got it, thank you.
All right. And then the right, so we were on some of the limitations. So we dive into the commercial building example. Okay, so this is an office building, like 3-story, 40,000 square feet, inspired by the Board of Building Water Supply, sort of basically the same, same dimensions. And here also, just kind of recommending thinking about like an energy target before you start your modeling exercise. Here we're saying the 2030 challenge, the year 2025, the idea is we're going to be 90% better than a 2003 baseline. The zero tool output shown on the right gives us what those numbers would be for a building of our size and our climate. So it shows a baseline EUI of 89, which is the median building. So our target would be a 9 EUI, which is quite aggressive and will need some, renewable energy conservation or renewable energy contributions to make it there. So let's just keep in mind that 9 target EUI when we're looking at the model. So Sapphira is the first tool that we're going to look at, and then Jess will talk about Autodesk Insight afterwards. You can use either SketchUp or Revit to do your 3D model, and then it does energy simulations with Energy Plus. It has a number of features that you can measure and lots of reports that we'll see. And it does 2030 reporting, and then there is annual license fee on top of the Revit or SketchUp fee. The workflow is illustrated here. So you could do, for example, SketchUp and use the Sapphira plugin to create your model. You'll develop the model, you'll choose a building type. You could do energy and or daylight analysis. So you can also do daylight analysis, but we're not going to look at that today. You can do some basic adjustments to the envelope and load inputs like lighting, and then view kind of limited energy results. You could also view daylight results. So that's what you could do in the plugin, either in SketchUp or Revit. But then you'll want to go to the web app and upload to the web app where you can define alternative concepts. You can do a lot more input editing. There's something called a response curve analysis, which we'll take a look at in a minute. And you can view a lot more results. And then if you even want to, you can export an Energy Plus input file and model that further in Energy Plus. So the first step, we're going to do a quick video of creating a model in SketchUp. So if you use SketchUp, this will be familiar to you. It would be probably a similar process in other tools. So here, just like building up one floor of the right dimensions, you can add windows. To make them windows, you apply a glass material to them, and then SketchUp knows that they're windows. And then here, just using a feature to copy that window and then multiply it along the facade. And if you've got a building that's got the same floor plan, you can just copy the ground floor and then copy it up to the second and third floors. And so so now you've got a 3-story office model. And then let's look at opening the Sapphira plugin. So you'll have to install the plugin within your tool, and it gives you this dialog box on the right. It has this entity palette where you can check that it's identified the roofs and the walls and the windows correctly. And then you can choose a building type just from a couple options and choose a location, like Honolulu, for example. And then there's some limited properties that you could adjust, but we're just going to look at the analysis. You click Analyze, it gives you EUI and some end use results, and then it shows you this breakdown of loads, which might be useful for thinking about your design priorities. But then you'll probably want to go to the web app. So here we'll just look at the process of uploading to the web app and creating a couple alternatives. So there's an upload button, and then it'll take you to a web browser. You create your new project, give your project a name. And then it creates a concept, and you can see results. You can change what's viewed in these columns for each concept. You can change the HVAC system if you want. And then here are a bunch of envelope inputs that you can vary. You can also change space usage like lighting power or plug load power. And then when you're satisfied, you can clone it. And we're going to call this SHGC and modify the input for solar heat gain coefficient to be like clear glass. And then we run that simulation and we see, okay, the energy use has gone up like we'd expect. We can see there's some standard charts that we can use to compare the impact of those alternatives. And then one more cloning. And in this case, we'll add overhangs to the clear glass. And so you go down to the shading tab and you can define some overhangs by projection factor and simulate again. And then you'll see it saved a bit of energy, still not as good as the base case window. And sorry for this really quick tour, but we do want to get a lot of stuff in today. And we can, if you have some questions, be sure to note them down and we can try and get back to them. But one of the great things in this Fira web app is they have this function called response curves. So for most of the inputs, you can select it, you can define a range and a number of steps, and then it'll do a set of simulations and show you the results for basically the sensitivity of that input. So here we're back to our baseline and we choose solar heat gain coefficient ranging from 0.1 to 0.9 in 5 steps, and we want to see the EUI results. So it'll run the simulation and then show you this chart. So you can see how sensitive the results are to that input. And you can also export to a spreadsheet. And then let's just look at the web app when we've defined a package of measures. So this is just a quick look at what that looks like. So here we have a whole bunch of measures that are sort of added incrementally, and you can see how the EUI drops with each one. And then again, you can download results for the chart or download results from the, well, you can put them into an Excel spreadsheet, for example. And then lastly, it has a link to the AIA DDX, so you can upload your project information to the 2030 commitment when you're satisfied with your model. Wanted to give here an example of response curve input. So here we're looking at EUI for 9 different variables, and the dashed lines are the baseline performance. So we can kind of see how, as we vary that variable, how it diverges from baseline performance. So there's building rotation. The 90 degrees would be facing the long directions facing east-west. So the energy use goes up quite a bit. And then there's the window wall ratio. It drops as we lower window area, window solar heat gain coefficient, and so on. Overhang projection factor, side fin, window U factor, not a huge difference in Hawaii. Roof value, R value, wall R value, also not a big difference on this particular building, but lighting power does make a pretty big difference. And EUI is definitely important, but there are other things to consider. So say, for example, you're interested in HVAC sizing impacts. some measures might have, a bigger impact on loads than they would on energy consumption. So you could see that here, having a building rotation, big east and west facing glass has a big impact on the peak load of the cooling system. So that's a cost for the building for sure. And I want to also just show these package results again. And as I noted, you could build your own graph in, say, Excel. And so here we're just seeing, as we incrementally add measures, how does the EUI drop? And then if we want to get down to a target of 9, we could add a PV system in Sapphira. And this happens to be a 7,000 square foot array, which is about roughly half of the roof area, would get you down to a 9 EUI. So it kind of gives you a rough idea of the feasibility of reaching that target with renewable energy. Sorry. The back buttons don't work very well. Right, strengths from Sapphira. So rapid model creation with default inputs, you can really quickly create a model and you can get some basic results using the plugin. It's really quick to add and compare concepts in the web app, which is nice. That response curve analysis is really nice. You can export results data. You can export the Energy Plus file, as I noted earlier. And you can do daylighting simulation in the plugin. There's some pretty good online tutorials. On the limit side, there are some limits to model complexity you'll run into in the plugin if you add a lot of shading devices like overhangs or side fins and so on, then it may not run. You can't adjust the solar reflectance. Utility rates are fixed. So if you want a different rate, you'll have to calculate that outside the software. And it does use an older version of Energy Plus, which is not necessarily a problem, but it's just something to be aware of if you wanted to export the file and then run it in a current version. So now we'll invite Jess back to the stage.
Thanks, Eric. That was a great overview of Sapphira. I'm going to be touching on Autodesk Insight and using the same exercise with the Board of Water Supply building. So Autodesk Insight is basically Revit's energy modeling software plugin, whatever you want to call it. It's really capable of energy, and so uses Energy Plus on the back end to do its calculations. But they also are trying to get more involved in the embodied carbon space. And so Insight does provide some of those calculations as well. You can change a variety of different things from envelope to your HVAC, but you're going to see that it does require some setup and some process to get us there. But the report of it, you can get loads, you can get HVAC sizing, but really their focus right now is whole carbon. There is also AIA 2030 reporting through Insight, and then you get it automatically by just having a Revit license, which is why we wanted to talk about it today, since Revit is just so familiar across AEC. So this is the Insight workflow. Really, what you should know from this is that within Revit, you're setting a lot of the basic inputs for the building. And then once you get that set, so geometry, HVAC system, all of that jazz, then you put it onto the Insight cloud. That's really where Insight lives, and it opens a browser and you can change a variety of different things within the building with like orientation, window to wall ratio, but there are some components that you can't change in Insight. And so you do sometimes have to go back into Revit, change it in Revit, go back to Insight. But you'll see that Insight also is where the whole carbon results come into play. So hopefully this works good. This is really just setting up the geometry. So this took me a lot longer to model than I want to admit, but basically I just made a similar model to what Eric did in Sapphira with basic envelope values, I used massing and site, if you've ever used that. And really what I want to do is say that this building is an office building and it has this type of activity within the building. And so I just went to the manage tab. And then we're going to be playing with the mechanical settings. So for those who haven't touched these, hopefully this is new and exciting to you. They have default activity templates in there already, but I want to change my lighting to 0.8 rather than 1, and my power density to 1 instead of 1.5. And so you can make that custom activity template by making a copy within Revit. So that's what I'm basically doing here. The rest of the inputs seem good to me. And so I click OK, and now I have a building activity template. You can also change the schedules in here. They have default schedules for your equipment, your lighting, all of that jazz. So you do have the option to change the profile of that if you so choose to. Okay, so that's all of what's happening in the geometry of the building and inside the building. The next step is actually to hook it up to an HVAC system or to create an HVAC system. And so we go to System Browser within Revit and go to Analytical Systems. You can add water loops, you can add air loops, you can add zone equipment, really exciting stuff. So this is me adding a cooling tower and then a chilled water loop associated with that cooling tower. It's pretty straightforward and kind of guides you through what information it needs. So that was me connecting the two. And then right now I'm gonna create a air side system. This building's gonna have an air handler in it. You have the option of adding a heat exchanger, and then you have the option to set it up to your cooling loop that you already created. We want a variable volume system. And then finally, you add your zone equipment. I'm just thinking VAV boxes in the spaces. So they have a bunch of different options for you, whether you want a fan coil unit, a VAV box, all of that stuff. So Insight and Revit do require some experience with mechanical systems. So that's something important to know about it. And then our next step is to assign the zones within the building to that HVAC system. So we're gonna go to a floor plan, and I don't have any rooms in here, but I'm assuming that this whole room is one zone. And so I basically draw the boundary of the zones that I want to hook up to the HVAC system. And then right now, assign it to the zone equipment that I already created in the previous video. So I feel like this is really the hardest part of the entire process, setting up the HVAC system and then assigning zones to that HVAC system, but it is going to set you up for success. So I thought we'd go through that. And then we are going to create an energy analytical model. This is a simplified version of the geometry that's already in the building, but we make it so that Energy Plus can read it and can understand it. And this is also where you really put your settings and your inputs in. So I'm going to go ahead and you can change the location within Revit, but then go ahead and go to energy settings, and you can define what mode of, I guess, energy model creation you want to use. So you could use your rooms or your spaces, but in this case, I'm going to use the masses and the building elements that I've created. Oh gosh. Okay. And then the rest of these inputs are relatively straightforward. I'm saying that we want a perimeter zone depth of 15 feet. which is pretty standard. Like usually if you're within 15 feet of a window, then you're gonna have a different sort of heating requirement or cooling requirement, which is why that's important to note. And then you go to your advanced settings to add some more cool stuff. Basically, you have the option to, I basically made it the same HVAC system, like that I did when I created the HVAC system. So that's me making sure it's VIV. There's also building infiltration class. So maybe you're doing an existing building and it's really leaky, you can change that infiltration rate. I'm assigning it to the activity schedule that I created earlier, and then also making sure that my HVAC system aligns with the one I created. And then this is something really important to note. When we get to material thermal properties, we have conceptual types, and this is a general, like, lightweight construction. You can choose which one you want, and it's just gonna assign the walls to this general package of envelope information. When we go to schematic types, you can click override, and when you click override, then it will take this construction instead of the one in the conceptual point of view. So as we get progressively more detailed, it's gonna get like, it's gonna override each other, basically. And then for detailed elements, this would be if you have envelope values and envelope construction within your Revit model itself. So that's when you would use that. And then you click create energy model. Yay, we're finally getting something that can go into Insight. And then this is what's created. A bunch of surfaces, a bunch of volumes, but something simpler for Insight to work with. Okay. So then you click on Carbon Insights, Analyze, and you send it to the Insight Cloud. And so this is its loading, and I'm going to skip to it. It opens up a browser and it opens up Insight. This is the Insight dashboard, and what it does is it brings in all of the inputs for the energy analytical model, and it runs a variety of different things. So we see total carbon here. There's a option between embodied carbon and operational carbon. There's the embodied carbon values. So you can see that in this example, roofs are a huge component of the embodied carbon. And then it also gives you an EUI breakdown, and you can change the amount of years that you're looking at. So if you want to see long-term how operational carbon compares to embodied carbon, you can go ahead and do that there. The custom dashboard, the dashboard allows you to basically look at what you want to analyze. So in this case, I want to reduce the window to wall ratio on the north side of the building. And so I can go ahead and put in the values I want to, 25, 50%. Right now on the north side, it's basically 100%. So we'll likely see a decrease in energy use because we're reducing that window to wall ratio. And Insight allows you to create these factors and simulate them to get your energy results within Insight itself. So this is me creating my own custom dashboard. There is a lot of flexibility in it, but you do have to kind of get used to the interface. So this is me saying, run the north window to wall ratio, simulate it, and I think, yeah. So the baseline case at 99% was around a 40 EUI, and then when we drop down to 25, it's a 38 EUI. And so what I did was I added a bunch of other energy efficiency measures, including like the south wind to the wall ratio, the building orientation, lighting power density. And Insight allows you to click from these options and kind of play with how you want to optimize. So maybe I want low wind to the wall ratio in both the north and the south, but I want also a 90% building orientation. It does this all and it changes the values of energy use intensity, embodied carbon, and cost. And then these are all of the factors that you can assess within Insight. What is a little bit tricky is when you get into factors that you can't change in Insight. So for example, I wanted to add the shading that the Board of Water Supply building has. I had to go back into Revit, model those, and then resend it to Insight and run that there. Another thing that you do have to change within Insight is if you have layers of envelope assembly and you want to analyze those layers, you have to go back and do it within Revit and make sure that you click the detailed material settings, basically. But this is it uploaded to Insight, and so you can see it brought in the shades, and it also saves the dashboard that you made previously. Like I said, there is AIA reporting available. This is how you do it. And some observations with Insight is that it can be used at any point in the design process, like from early concept through construction, basically, because of the level of detail that it takes in. But with that level of detail, it does get a little bit confusing. That being said, you could start the model and then maybe pass it on to somebody who does modeling more often. It does embodied and whole carbon analysis, runs combinations of efficiency factors, and then you can export the Energy Plus file if you want more detail. There's also a bunch of tutorials online and it's accessible with a Revit license. And then some limitations. It is a higher learning curve than Sapphira or HEAD, like you've seen, and it does require basic HVAC understanding, like what connects to what. It's not as rapid of a tool, and there's just not as many things that you can change in Insight, like going back and forth between Insight and Revit. And then also Autodesk is like redesigning their package of energy modeling tools. So there's Forma, which we'll talk about later, but this might look a little bit different in a year, depending on what decisions they make with Insight. Okay, yay, I'll pass it on to Ron.
Thanks, Jess. So that was a lot.
Yeah.
We're gonna take, it's important though. We are, however, gonna take a huge step backwards with what I'm gonna tell you about C-scale. So in a way, we wanted to make sure that we did C-scale last, just to show the differences between the two softwares that we've talked about so far and how different C-scale is. So I'm gonna start with, firstly, just a basic overview of what you can do with C-scale. So C-scale is not like these other softwares that we just talked about. It's not entirely an energy modeling software. In fact, it does very little energy modeling at all. Mostly it is an embodied carbon modeling tool. So its focus is on carbon instead of energy. What it does for energy is it uses that same zero tool that Eric went into way early on into the slides. And it sets a target based on what the 2030 commitment says you should be doing around now. It can, however, go into all kinds of carbon reduction measures, massing, structure, enclosure, refrigerants, it's a big one. It will give you EUI estimates, but based on targeted benchmarks. So no actual analysis is done on anything. Like you can't do, if I'm reducing the windows by this much percentage, what's going to happen? It's not going to tell you an energy number. But if you do reduce your windows, it will tell you what kind of a carbon impact that might have based on how much massing you might need to get rid of. You can also do 2030 reporting through this. And there's no licenses involved, so it's free to sign up for. This was a pet project that EHDD put together initially. They're a large architecture firm. They have kind of spin off since then. It's its own firm at this point, but for now, licenses are free. And I just want to go into that graphic at the top right there, that C-scale is really meant for concept level design analysis. So it's from before SD, before you have any sort of BIM model whatsoever. The other two softwares that we just went through, you had a 3D interface. This does not have that at all. So with that, let's move forward. Like I said, there's no 3D model, so you don't need to create a geometry. It's pretty simple how you get started. You just hit on new project, give it a name of some sort, say it's new construction, or if you're doing reuse, set a target completion date, and then set an address for where your project is going to be located. It's going to figure out exactly where that is. And you'll notice, as I put in the Honolulu address, it changes the zone information for what kind of ASHRAE zones you're in. Set a few more basic descriptions, square footage, how many stories there are. And I'm clicking a few more of the categories to be analyzed here, which is everything. So it just sets you up with this one baseline to start with. What we can do next, what we should do next, is edit the baseline to get it to be like what you want the building to be. So that's what we're going to do here. Again, the zero tool is based on CBEC's benchmarking, so the Commercial Building Energy Survey, 2003 version. So based on that, it's going to pick the right target from what the 2030 challenge tells you it should be. You can change a few basic things like saying what the building perimeter is going to be, what the floor-to-floor heights are going to be, window-to-wall ratio. And that's about it for geometry. You're not creating anything, and it's not going to show you a visual for any geometry either. Once you have done that, you can change a few more things like structure and enclosure bits. What you're going to change is just essentially drop-down options of low carbon, average, or high carbon intensities. And these are all taken from the Carbon Leadership Forum's benchmarks that they have done for MEP, architectural stuff, as well as benchmarks from the Structural Engineering 2050 Challenge. So it's a lot of benchmark data. All C-scale is trying to give you very early into the design process is an idea of where you could land based on other buildings that have been built in the past. So, a few more things that you can change. Enclosure, I have set everything to just average because I felt like that's what the default typically is. I'm not going to change that for this. And I don't really change very much else here, so I'm going to skip to the next slide. The next thing you can do in C-scale is set up a few more scenarios. So I've set up a whole bunch here. You can also hide them so that it's not too cluttered while you're going through it. I'm going to hide a couple of these scenarios and just keep 2 alive, which I actually took from what Jess and Eric had done previously. Setting the zero tool target to an EUI of 9 and reducing the window wall area to 40%. So, like I mentioned before, it doesn't do any energy analysis on its own. All you're doing is setting different targets based on what the zero tool is telling you. C-scale really should work well with other modeling tools. So it's not an energy modeling tool by itself. What you need to do is to pair it with something like Sapphira or Insight while you're doing your design iterations. So I just want to point out a few things that you can do early on with C-scale, and then how you should perhaps go and do a little bit in an energy modeling tool. So I changed the window to wall ratio here to 0.4, so 40%, whereas the BWS building has an overall wall ratio of about 65%. So it's highly glazed. Notice that it does not change the energy use at all between the 2 iterations down here, because it's not an energy analysis. What I had to do was I went to Eric's set of clones that he had created. I noticed that his changing of the window wall ratio resulted in a 3% decline. And so I plugged in an additional 3% decline into mine. However, changing the wind wall ratio does affect the enclosure carbon. So you'll see over here, it says about a 7% drop in overall carbon for enclosure. That's essentially taking into account that if you have less windows, you need less structural support, you can reduce a little bit of your embodied carbon overall by doing that. So again, point I really want to get out there is that C-scale has its uses. You need to know what your goals are with this tool. And you need to be able to pair it with other tools that make sense while you're doing your analysis early on. I don't really think I'm doing too much else here, so I'm going to skip to the next.
Ron,
Yeah, go ahead.
I may be missing something here because I've never used it before, but can you help me understand what the outputs are other than a target? Like, is it actually suggesting material assemblies, or are you putting in the assemblies as well and it's figuring that out?
No, so it does not go into that level of detail where you can actually put in the assemblies. What it will do, however, it's looking at the Carbon Leadership Forum's benchmarks that it has put out there, right? So the Leadership Forum went through, and it went through a bunch of different buildings that have been built over the last 50 years, right? And it has a top 20th percentile of low carbon buildings, a mid percentile of average carbon buildings, and a bottom 20 percentile for high carbon buildings. So when you change those goals, all it's showing you is like, you're aiming for that top 20th percentile, you're aiming for the very middle, or you're aiming for the very bottom. You're not actually getting analyses on how changing a different wall assembly or a different assembly of any sort is going to affect you. It's letting you set goals of, does it matter if I were to aim for the very 20th percentile, or should I be doing something else? So I'm going to move to the results page, and I think it'll make a bit more sense as to like why even do this. Right, so here is all of the different scenarios that I had come up with, right? All the way on the left is the zero tool baseline from the 2003 CBEC survey. You can see that the red is the embodied carbon, the blue massive chunk there is operational carbon. This is based in Honolulu after all, right? The next one is the zero tool target EUI of 9. All we're doing is just setting the energy use target to be 9. What do we see from that? That the biggest chunk of whole life carbon goes down by a whole lot when you target energy use. Essentially, that's what it's telling you. The rest of them, you know, wind to wall ratio, it goes down a little bit. You can kind of see just a little bit of a difference between these two. If you add PV, you essentially get rid of operational emissions entirely, and all you're left with is refrigerant emissions and embodied carbon emissions. But here's one where all you did was reduce embodied carbon. So I essentially targeted the MEP 2040 challenge requirements and the structural engineering 2050 challenge requirements. So perhaps you're working with consultants as your MEP consultants and your structural engineering consultants who are really serious about those goals. This is how much of a dent it makes overall in our current location. This would be very different if you use C-scale to do a model for somewhere in San Francisco or in the Pacific Northwest, where their carbon intensity of their grid is significantly lower, and their embodied carbon load for a building has a much bigger impact on the overall whole building carbon, right? The last one here is just if you combine everything. Again, notice like huge chunk reduced in overall life carbon when you get rid of operational emissions, but the embodied has barely moved. So for our location, it seems like it makes more sense overall, you get more bang for your buck, carbon, if you target your operations a bit more. And here's another graph that shows essentially just the same thing. That top line at the very top, that's the original 2003 CBEC target. The line right below that is what happens if you just do embodied carbon reductions. There's a tiny bit of a reduction at the very beginning, and it maintains that parallel to the same thing that the CBEC target would have had. All of the rest that have a massive chunk in reduction of overall emissions over 60 years, which I chose as the life cycle of this building, much bigger. So C-scale is very early design tool. It's just to help you set targets and understand what kind of decision should I make based on my location. It's great for firms that potentially have portfolios all over the including Canada, because C-scale is supported there. But But it's a tool to help you make some very early decisions before you've even come up with any sort of bin, before you've done any kind of other analysis. It can help you do some more work when you pair it with others, but it should not be used in a vacuum. I'm gonna add one last thing, just because Jess spent so much time on her insight model, right? No, like, I mean, you put so much effort into it, right? I did all of this in about 6 hours today, whereas Jess had to spend a whole lot more time, right? But I took notes on this just earlier. Jess's insight model gives you a total embodied carbon estimate of about 436 metric tons of carbon dioxide equivalent. The C-scale model gave me an estimate of 2,492 tons. So that's nearly 2,000 tons of carbon dioxide equivalent more. Why might that be? Any ideas?
The urban model is missing a lot of stuff.
Yes. She had to do this quickly, but the building in that model, if it were to be built today, it would crumble. There's no beams, there's not a lot of walls figured out. I think you're a curtain wall, right?
Yeah.
Yeah, so it was done quick and dirty, but it wouldn't actually stand up. There's a lot of detail missing from that model for Insight to do an accurate embodied carbon analysis. This, however, can give you a very quick, relatively accurate embodied carbon analysis based on benchmark data. It's not modeling much. It's just letting you know, based on what we've seen in the past, this is kind of what you're being like. So again, it has its uses, but it should be used carefully and most likely paired with a few other things. All right.
Thanks, Ron. Okay, we're gonna go fast through these additional tools. The first one is Climate Studio. You use Climate Studio within Rhino. So you have to have both Rhino and a license to Climate Studio. And you can do all the same things that you did in Insight and in Sapphira, but it does have a bit more focus on daylighting. So you can see in these photos, the lead daylighting credit, it runs those along with exterior lighting as well. I would say it's like an in-between of Insight and of Sapphira, in my experience. You can change your HVAC system, change your construction, and you're spending all of your time in Rhino itself. These are some more visuals that it gives you. It's a little bit more pretty, I would say, than maybe Insight, but you are paying for a subscription to it. And then we did want to touch a little bit on Forma because we have seen it come up in discussions. Forma currently is with Autodesk and you do need an additional subscription. So it's not like Insight where you get it with your license. I believe you do need to pay for some annual or monthly subscription. And this is an environmental analysis. So it does no building energy modeling, but you can look at daylighting from a site point of view along with noise level and the wind. So microclimate and site analysis rather than energy modeling, which is the discrepancy that we've been seeing, basically. Okay, I'm gonna pass back to Ron.
Okay. So I kind of already did this, but I'll just state it again. So a summary comparison between the three main topics or softwares that we discussed, right? We've got Sapphira, Insight, and C-Scale. All of them have strengths, a few weaknesses to them as well. Sapphira works really well early on. You can do a decent amount of design detail to it. You can work early as well, keep it pretty shoebox if you'd like. The limitation with Sapphira is, and Eric kind of alluded to this, is like the more detail you do add, like the BWS building has a ton of horizontal shades as well as vertical shades on both sides of its longer facade, right? 80 windows overall, both with twin horizontal and twin vertical. Sapphira starts slowing down a little bit when it's doing an analysis of that level, right? So it's really good early on. You can do it pretty quickly. It has a web application, so you don't necessarily need to download all of the software onto a laptop to make it work. You don't need to worry about how powerful your laptop is, let's say. Insight, very powerful, right? You can do a lot with Insight. You could take it to essentially a DD, perhaps even a CD level model. You can't get energy credits for it typically, as far as I know. Do you know if you can get like modeling credits for LEED?
Well, it gives you your energy.
Okay, yeah. So there might be a chance that you could get LEED through that, which also means you qualify for Hawaii energy credits. And then lastly, you have C-Scale, which is kind of like a way different kind of tool entirely. It doesn't go into energy at all. It's mainly a carbon tool, and it works really well when you iterate it with other tools built together. So in summary, no tool is perfect. You kind of need to choose what you are trying to do with the tool and then pick the right tool. Yeah. Yeah, and I'm gonna pass it to Sophia to talk about some Hawaii energy incentives real quick too.
Hi, everyone. Sophia, Energy Advisor, Hawaii Energy. Thank you guys so much for this informative, panel on what's going on with new construction. I've definitely never heard of these, energy models before, like Sapphira and these other tools that you can use, but it's something that I get to learn about every day. And I'm here to actually just talk about the specific Hawaii energy incentives that you can apply for should you be using energy modeling for a new construction, new build. So this is going to be quick. I want to be mindful of your time, but essentially we have two different types of approaches for looking at new construction. If you are in the conceptual schematic, early design and development period, then please reach out to us. We are looking for early engagement to review these energy models that you might have put together using these cool tools. We want to see that there's at least 10% energy savings over the standard code for both of these approaches, but that's really where you're going to be receiving Hawaiian energy incentives. So we can cover up to 75% of the costs that you put in towards getting that energy model done. And we will incentivize that up to $10,000. So after you have done energy modeling and you have gone through the construction phase, we will then also provide an incentive of up to 18 cents per kilowatt hour saved through the implementation of the 10% above code equipment and materials that were used for the new construction. We do cap this at 200,000. So really what I want you to take away today and share with your team or your boss is to say, hey, I learned last night at the super cool AIA event that if I provide Hawaii Energy, our energy model, and it meets this criteria, we can get hundreds of thousands of dollars. So that's what I would love for you to take home today. And, don't fear if you have not, reached out to us during the conceptual design phase and you have already started construction, do not worry. We can also go with the systems approach. So it's basically going to be our standard prescriptive rebates, where as long as it's again 10% better than the code, then we can provide incentives up to $150,000 for that build. And this does have a fairly limited scope in comparison to affordable housing. We do have additional incentives there, but as long as you're looking at lighting, HVAC, water heating, and any Energy Star appliances, then we definitely want to see if we can incentivize that for you. So there are additional incentives for multifamily. So if you are working within that sector, or if you are working on any projects that you think this might apply for, please feel free to see either myself or a few of my amazing teammates here after the event. We have Eileen, our business solutions manager. We have two new energy engineers with us tonight. And I'm Sophia. I work in the commercial office and retail sector. But if you have any questions related to how Hawaii Energy can help support you receive incentives for your business and doing these energy models, we'd be more than happy to talk story with you and learn more about your project. So thank you so much. Oh, yes.
So is it after like the kilowatt saved, is that like after you
either in operation, or how do you?
Yeah, so because we go from a custom approach for this, we can actually, let me put it right. We will forecast that based on the plans that are provided. And yeah, we base it on the first year projected savings. So we don't have to do it like in real time where that year has passed. We can do it upon the completion of the build using the forecast of projected energy savings within that first year.
And who does the $2,000 or up to?
Yeah, so we can provide that rebate check to the company, to the contractor, to whoever is negotiating between the client and the customer and the contractor, really. We can give the rebate to anyone. So as long as that's established, you know, going into the project, the contractor might want to leverage that, the architect, the customer might want that directly. Yeah, it can go to anyone.
So Sophia, this is Eric in the ether. There was a question online about how someone can contact you, what your contact information might be.
Yes, I will put that in the chat, but you can always go to www.hawaiienergy.com. And we have a generic email that is monitored every day, and you can reach out to us there. But I will also leave a business card and try to put some information in the chat for those who are online.
Yeah.
Okay, cool. And yeah, feel free to come see me after. I can connect you with the QR code on my phone that'll take you directly to our website. And I think this will be helpful, just on a side note, that if you are also engaged with the city and county's Better Buildings benchmarking program, I'm kind of the Hawaii Energy liaison for that. So if you are looking to get more information on energy use intensity, EUI scores, and what we're doing in conjunction with city and county, I'd be happy to share. And then, yeah, I have a shameless plug that we are hiring, and we are also looking for interns. And so if you are curious or interested about energy efficiency and what we do at Hawaii Energy, please also feel free to see me after.
Thanks, Sophia.
I just want to echo one thing real quick that Sophia mentioned, which is, as we're talking mainly to architects, even if you're not planning to do an energy model or thinking of incentives whatsoever, reach out to Hawaii Energy when you're starting thinking about your project anyways, right? One thing I'm gonna echo that Vin, who is part of the Hawaii Energy team, kind of tells me often is that sometimes people don't reach out to Hawaii Energy early enough and they're like, we just need the model, it'll be fine. We've got lead scope in our project overall. We'll submit the lead model and it'll be done. That doesn't work because you need to be comparing it to our code baseline, not the lead baseline. So there are a lot of folks that submit a lead model hoping to get that $200,000 and they can't because you need a whole different kind of model, right? So reach out to them early on. They can help you iron out some of those thoughts and decisions. If you don't do a model, fine. Maybe they'll help you get some of the other kind, the prescriptive kind of resources, right? So just reach out to them early, doesn't hurt, and they're not going to charge you. So thanks.